do this all this week. We're going to work on Chapter 5 arrays, and we're going to skip this section in our textbook, page 175 to 184. If you do in programming languages, parallel arrays, you'll cover it then, because I'm just basically wanting you to understand the logic between or just about the simple arrays where we initialize array, load it, print it out, or do something to the values in the array and then print it back out. That's what this chapter, what I really want to get out of it. I don't want real complicated things going on with arrays. I just want you to basically understand the purpose of an array and how much more efficient it is to code using an array rather than a string of if-then else's, and we're going to see that in some sample problems. So we will do up to page 175, and then we'll pick up again in the middle of page 184 with remaining with array bounds and the for loop. So that's what the lecture will be. And the chapter work, part 1, this is the assignment that's not due until next Tuesday. Is that April 29th or is that Monday? I meant to say should be, that's Tuesday? Okay. So that's when the number 2, A and B, but we will do number 1, A and B in the exercises in class together. And hopefully by Thursday, that's what we'll basically, we won't have much more of the chapter to do, and we'll be working problems in class. And this zipped file are some problems that we're going to go over in class as we go along in the chapter. So I just went ahead and included them there in Evernote. And then you'll notice week 14 I already have lined out. Hopefully this schedule works. I try not to do too much in advance so we can be right where we're at, but this is where we need to be by the end of the semester. So there will be chapter work part 2, but we're going to do the part A of this problem together in class, and then your assignment will be the part B of the problem, and then I will give you the last assignment, which will be similar, to what the last test will be, where it will include arrays and methods, the hands-on portion. Okay, so that'll be, I might post that before this week is out, so those of you that are, get way ahead, you'll have time to work on it. So the whole last week before finals, we will be working on that assignment number 4 on that Tuesday, and then on that Thursday, I'll go over it to make sure you understand what will be on the final. And finals week, I would like to do on Tuesday our final, but if students have other classes on Tuesday, then I'll have to wait and do it on the Thursday. So I'm going to look at that as it gets closer and everybody's looking up their final schedule where you know for sure we'll discuss that. Okay? All right, so that's where we're at. So let's start. Does anybody have any questions about any of that? Just stop me if you do. Okay, I'm going to pull up the PowerPoint then on arrays. Let's see. Should be, oops, come on. Which will be chapter 5. How many remember arrays in mathematics, algebra, whatever, if you had algebra? Everybody's had algebra, I know. So Kat remembers. Anybody remember what an array is? Something you didn't like? Like a table, maybe they were called tables, but in algebra I think they were called arrays. And what an array is just a way that we're going to store data. Let's see if I can. I remember when I put this up, I think it goes a little bitty, so I'm not going to be able to do it if I remember. Yeah, I cannot figure out how to get it to go bigger, so I'm going to have to do it this way again. Okay, so here's the objectives in this chapter, and we're not going to do everything that's in these objectives. We're not going to do using parallel arrays or searching an array for range match. But the rest of the objectives, that's what we're going to cover. How you store data in arrays, how an array can replace nested decisions, using constants with arrays, searching an array for an exact match, and remaining within array bounds, and using a for loop to process arrays. So remember how I told you everything that we've learned up to now, we have to use that to be able to process arrays, except for the functions we don't have in here yet, but we will actually do that at the end too. At the end of this chapter, we're going to create functions or methods, whichever you want to call them, out of some of our array routines. Okay, so storing data in arrays. And if you look there on page 159, it even shows us how you would normally, when you declared, if you had that many variables, you had 3 variables, you would have to initialize each one of them, input each one of them, and output each one of them. So that's why we're going to learn an easier way where it only takes one statement and a loop for each one of those things, no matter how large. Say we wanted to use 10 variables. If they're all representing the same type of value, we can store them all in an array. So there's a need for handling large amounts of data. If our program is like that, then we would use individual variables, but they would become very unwieldy. In other words, very hard to keep track of. So we have something called an array that is a type of a data structure, which is a collection of data items that are organized for efficient use. An array is a type of data structure. Now, if you were taking just straight a computer science degree, programming for your bachelor's degree, say at UCO, one of the first classes I had to take was called data structures. And there were more than just an array, but the one that we're going to talk about is the type of data structure called an array. There's ones called trees, there's all different binary tree, there's a lot of different ways that the computer stores data. But this is the way that you will use in every programming language that you were to take. You need to know how to store data in an array. And that's why we cover this in the logic class. So here's what an array is. It consists of a series or list of values. All the values have the same name and same data type. So in an array, you couldn't store one numeric value and one string value in the same array. It has to be data type, all numeric or all string, and they have to be the same size. Okay, so they would all have the same name, but you're storing a collection which is several values in slots. So instead of having to say value 1, value 2, value 3, value 4, and so on, we're going to say value sub 1, value sub 2. We're going to position them in certain location in memory. And we're going to draw a picture here that'll help you. All values have the same name and data type. They are differentiated with subscripts, sometimes referred to as a table or a matrix. When I used to code in COBOL, they called it a table. There are some languages that call them a matrix. So if I look at this one, how do arrays occupy computer memory? Well, if we look over on page 160, here are those terms that I was just talking about. And if you look in the example, it says num sum vals 3. So what they've done is they've set up a data type called sum vals. A variable name. This is a variable name. And they defined it like if we were in JavaScript, we would say var sum vals. Now, let's say that we're going to put 10 values in there. Then we would define it as some values sub 10 when we declare it. We'd say there can be 10 different values put into some vowels. Now, what it shows you there is if I wanted to access, say, the 5th position, this would be a single array, and it's called some vowels, and it has 10 slots. 10. So this one, the thing is, in an array, it would start with 0. So this is not the value in it. This is the position of it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say I had 5, 2, 1, 1, 0, 4, 3, 5, 6, 7. These are the values that are in each one of those slots in memory. Okay, you see the difference between the position in the array and the value in it. So if I said, what is in position some vowels sub 4? What's in the 4th position?
0.
Now that is not number 4. What is it? 0, 1, 2, 3. Remember? You have to start with position 0 in an array because we've been conditioned to think in our decimal numbering system that it's 1 to 10, but it's really not. It's 0 to 9. Remember, we talked about that earlier. I can't remember which that came up. So if I said some vowel sub 4, it would be equal to 1. Okay? So that's how we locate and store and tell it which position to store it in. So we're going to, you see where we're going to do loops, maybe you can see that. But if you look, here's the example. Oh, what did that do? Here's the, oops, it added me a page on my PowerPoint. Okay, oh, let me go back to this. Okay, so the size of the array indicates the number of array elements that are determined when the array is declared. So that's what I did with some vowels sub 10. That array has 10 array elements. The array declaration, its declared structure containing multiple values. The variables have the same name and data type. Then in order to populate the array, which is what I did when I just put a bunch of numbers in there, right? That was populating it. I'm going to assign values to the array elements. So the array elements are 0 through 9, right? I assigned elements to them by just putting them in there. Array syntax is square brackets usually hold array element subscripts. You notice that's what I used was square brackets. That's what JavaScript uses too. I'll show you. But we're going to see some in JavaScript. Okay, so if you look down at the bottom of page 160, it shows you just what we were doing. This one, the declaration, num sub vowels 3, it's saying that it's only going to hold 3 values. And some vowels sub 0s, 25, some vowels sub 1s, 36, some vowels sub 2 is 47. And so if you look on page 161, it just has a block of memory demonstrated or illustrated abstractly there with a little table. And it says, say you're in memory and it's got a 3-element array in computer memory. That's what it would look like. Well, if you look at it, it says you can assign array values or you can assign values to elements individually. This can be done when the array is declared. So when you declare it and say num or var sub some vowels sub 3, in JavaScript we'll see how we do that. Then we can go ahead and say some vowels sub 0 equals 25, some vowels sub 1 equals 36, some vowels sub 2 equals 47. Or you can assign the values this way in pseudocode, okay? All it did was, there's 3 elements, so it's saying put 25 in the first one, 36, and 47. Okay, that's how you just say that you're assigning the values. It assigns the values when the array is declared. So that's what it's going to look like. How arrays occupy computer memory. Okay, let me see where this is. Yeah, this is over, I'm trying to see what page that is. Some vowels, seeing if that goes way on over. I don't want to go that far yet before. Well, we'll look at this one, and then I'm going to show the video that you probably didn't take time to look at, understanding arrays. Okay, after the array is declared and the values are assigned, then the data items can be used in the same way as other items of the same data type. They can be input or output, and numeric items can have arithmetic operations performed on them. So in order to address the value that's in some val sub 0, because it doesn't have a separate, these don't have separate variable names, that's how we say whatever is in, answer is equal to whatever's in some val sub 0, which in our case, what's in some val sub 0? 5. So answer is going to be equal to 5 plus what's in some val sub 2? 1. So answer would be equal to 6, right? Everybody see that so far? Any questions? How they came up with that? How we got that? So instead of having to have 3 separate data names and variable names, we have one variable name with subscripts.
This is Joyce Farrell. This video is about understanding arrays. An array is a list of contiguous values in computer memory. An array has a specified size. Each item in an array is an element. All elements in an array have the same data type, and each element can be accessed using a whole number called a subscript. The subscript values go from 0 to 1 less than the size of the array. For example, suppose you declare a 4-element numeric array num money 4. The elements then have the name money 0, money 1, money 2, and money 3. The subscripts go from 0 to 3 in a 4-element array. You can assign a value to an array element. For example, money 0 equals 14, or money 3 equals 82, or money 1 is 6. You can change the value in one of the elements in an array. For example, you can change money 0 to 9. Or do arithmetic. For example, money 3 equals money 0 plus 10. You can try to assign money 2 to money 1, but if money 2 has not previously been assigned a value, this is illegal. You can try to assign a value to money 4, but money 4 is beyond the end of the array. It's not part of the array, so you should not do that. You can initialize an array when you declare it by making a statement such as num money 4 equal, and then list the values separated by commas. You can use a loop with an array. For example, suppose you have num money 4 and you declare a variable named x and assign a 0. Then you can say while x is less than 4, and it is because it's 0, you can assign money x, money 0, a 0. Then add 1 to x so it's 1, and end the loop. You then check, is x less than 4? Yes, it is, so you assign money 1 a 0, and add 1 to x, and x becomes 2. That's the bottom of the loop, so you check, is x still less than 4? And it is. So money 2 becomes 0 and x becomes 3. You're at the bottom of the loop, you check again. X is still less than 4 because it's 3, so money 3 is assigned 0 and x becomes 4. Now when you check again, x is not less than 4 and the loop ends. Thanks for watching.
See, that's why we need loops, but now I see how I confused you all. Let me erase this. Okay, the only time that you have to be concerned of it being one more that you define, it, and not whenever you're adding. So like if I define an array, let's just call it array sub, let's do it 5 since they did that one. We have an array with 5 elements, a num array equal to 5. So if I wanted to set those values, I could say 1, 2, 3, 4, 5. So there's got to be 5 positions in the array, just like she showed us with the 4, but we can do it with 5. So we've got 1, 2, 3, 4, 5. But what she was saying is this is array sub 0, array sub 1, array sub 2, array sub 3, and array sub 4. So the only way this is going to get you in trouble is if you try to assign something to array sub 5. These, I was saying it incorrectly in that you can say like answer equals, okay, and all of these have zeros in them. Before we do that, let's populate it with some values. Let's say now that I've gone in and I've said array sub 1 is equal to 10. So I'm going to change array sub 1 to 10. And then array, I can put a value in array sub 0. It can be equal to 5. Let's change it to 5. Array sub 3. So that's going to be here. Let's say it's 20. And then I'm going to assign array sub 4 equal to 15. And now, what she was saying is, what if I say array sign array sub 5 equal to 3? Is that valid? No, because there is no array sub 5. So these positions are accurate. This is 0, 1, 2, 3, 4. The thing that I have to remember is when I define the array, it's defined one greater than what my elements go up to because I start with 0. Okay? Is that better? Oh, you got it? Sorry for all the confusion. Okay. And you can watch that video over and over. Y'all have access to that. Okay, so now we're going to see it actually working in a problem. Over on page 162, we have a problem. How an array can replace a nested decision. So here's a human resources application example. So an HR example, right? So if you work somewhere. Produce statistics on employees' claimed dependents. The report is to list the number of employees who have claimed 0, 1, 2, 3, 4, or 5 dependents. Assume no employees have more than 5 dependents, okay? Figure 5-2 represents the typical report output. And then figure 5-3 is the decision-making pseudocode and flowchart. So here's what the chart looks like if there were 43 employees with 0 dependents, 35 with 1, 24 with 2, 11 with 3, 5 with 4, and 7 with 5. So figure 5-3 is the approach that uses individual variables for the decision-making process uses a series of decisions. So in this one, which you probably can't see at all at the top, this on page 163, it says significant declarations. So here's the declarations. There's a numeric variable called dependence, DEP, and then they've set up 5 counts, starting with counts 0. Now this is not an array. These are individual variable names that they've set up. Count 0, count 1, count 2, count 3, count 4, count 5. So they've set all of those up and set them to 0. And then they've used those to make their decisions. They're saying when you input the dependent number, then if it's 0, then add 1 to count 0. If it's not, then test and see if it's equal to 1. If it is, add to count 1. If it's not, test and see if it's 2. And add to count 2. If it's not, check and see if it's 3. And if it's 3, add 1 to 3. Then if not, check and see if it's 4, add 1 to 4. And then you can assume if it gets all the way inside the nested ifs, that it's a 5 and add 1 to that counter. And you notice with the pseudocode, there's 1, 2, 3, 4, 5 end ifs, right? Because those are all nested if then else's. All right, so that's one way. Until we knew about arrays, that's the only way that we knew how to do that problem, right? Okay, so now we're going to see a more efficient way to do it. On page 164, it tells us the decision-making process in figure 5-3 accomplishes its purpose and the logic is correct, but the process is cumbersome and certainly not recommended. This logic requires far more work than is necessary. Follow the logic here so that you understand how the application works. In the next pages, you will see how to make the application more elegant. So, in figure 5-3, we went through that one, how it works. Then on 5-4, they've done one thing different. What have they done different in the next one? Ooh. Yes. Kept all the nested if else's. So they're telling you this is a little better. At least you've defined, instead of 6 variables, you now have 1 variable with 6 spots. Okay. But we still have the nested if then else, and we are accessing the elements of the array. But if we look over on page, let's see, 5-5. Okay, 5-5 is still the flow chart. What have they changed on this one from 5-4? What did they do different? Oh, okay. They've put the subscript in as the variable name. So like in the one that she showed us, we use sub x. Well, they're using sub dependence. So they've done that, but they're still using all the if then else's. Now let me show you the difference here in, oops, what is going on here? I lost my, okay, let me show you the difference in doing it in JavaScript the 2 different ways. And these programs that I'm going to show you are actually in that zipped file, if you want, that I gave to you on chapter 5 array examples. Okay, so 5, I'm going to try to open both of these at the same time, maybe. Open. No, it's not going to let me do that. Okay, I'm going to open this one first. Okay, so this one is the JavaScript for 5-5. So this is the first example of an array using JavaScript, okay? And you have this example in Evernote. So what we've done with this flow chart 5-5, first we've initialized. This is a statement in a JavaScript array. This is the statement that defines or sets up in memory 6 slots, okay, for your array. And the array is called count, but in JavaScript you have to say, so this, I could not use this as a variable like I did over there in your example because it's a keyword in JavaScript. So it would say, set up a new array with 6 positions and name it count. Then I set up a variable dependent because that's what it says in figure 5-5. Here's our break. Variable index equals 0. And here it says while index is less than 6, count subindex equals 0. So here, what is this array doing? Or I'm sorry, this loop doing? When at the end of that loop, what will my array have in it?
Choosing a 1 in the first position.
What now?
Should have a 1 in the first position.
Okay, it says while index is less than 0, count subindex is equal to 0. So let's see what happens. Here's index. And this is our array. Let me pick the values out. This is count. And so it says to initialize count or 6 slots, right? So 1, 2, 3, 4, 5, 6 slots. Okay? Because that's what it tells me up in the beginning when it says count equals new array sub 6, right? But there's no values in it. So now it says index is equal to 0, right? So then it says while index is less than 6. So is index less than 6?
Yep.
Yes. Then it says count subindex. So count, I'm going to do it this other direction, the column, then I can probably do it 1, 2, 3, 4, 5, 6. So count subindex, which what is index right now?
0.
So count sub 0, set it equal to what? 0. And then it says add 1 to index. And so now index is 1, right? Right?
Yes.
Okay, so now take count subindex. So now at count sub what?
1.
1. Set it equal to what?
0.
0. Then add another 1 to index. So now it's 2. And so my loop says set count sub 2 equal to 0, right? So it's, what is that loop doing?
It's just initializing everything, making it
0,
even.
correct. And so in the book, it told us we could have done it by saying count sub, what was, where we could put 0, 0, 0, 0, right? In the pseudocode. But JavaScript, this is the best way to do it because you never know how large an array is. So if you were going in and just doing a string of zeros, it's not as efficient as if we go in here. So at the end of this loop, before it falls out, we will have each one of these slots initialized to 0. Okay, so it initialized 6 spots, 0 through 5. To now, what would happen if we said index less than or equal to 6? Would that work?
No.
No.
It would do it one more time.
It would do it one more time when we would be out of bounds, right? Okay, so then we say dependence equals Prompt the user to enter the number of dependents from 0 to 5, enter a -1 to exit. Type here. So then here we're making dependents to make sure it's numeric. Now we're saying while dependents are greater than or equal to 0. So here, why did we have to say greater than or equal to 0?
-1 to quit.
Right. And also we can have 0 dependents, right? So they could enter 0. So here are the if statements that are coded in our flow chart. If dependents are the same as 0, if it's the same as 0, then count sub 0 equals count sub 0 plus 1. So all of these counters are sitting there in memory. And so if I run this, as long as I keep entering numbers, it should keep adding to there. And then at the end, it's going to use that same loop, which was while index is less than 6, but instead of putting 0 there, it's saying print out whatever's in position 0, then add 1 to index, come up here, print out whatever's in position 1. You see how that's working? So it's the same loop. Anytime you want to do something with the array elements, you use that same loop. It's just whatever you tell it to do in between the beginning of the loop and before you increment it by 1. That's where you put the processing of that particular value. So if we're initializing, if we're storing numbers in it, or if we're printing it out, we're going to have that same while loop. So let's see if it works. Does anybody have any questions about that, what we went through? Okay, let's go here and run it. So, number of dependents. Let's say first one I say is 1. I'm going to say 3, 0, 2, 2. I'll do it a few times. Let's see, we have one in 5, 5, 4. Okay, so now I enter a -1 and it should quit. Print it out. Number of 0 dependents equals 1. Number of 1 dependents equals 1. Number of 2 dependents equals 3. 3 equals 3. 4 equals 1. 5 equals 2. So you should be able to go through that logic by hand and see how that logic works. But this was with the if then else, so that's still not a really good way, right? So we're going to look over on page 168 and we're going to do it a little bit different. So on the flow chart for the dependence report program on page 169, go back to the PowerPoint here. So here's how an array can replace a nested decision. You rewrite the decision-making process because action taken is the same for each array element. Oh, man. Oh, boy, something made me sneeze. All right, so figure 5-6 shows the efficient decision-making process. So in figure 5-6, what they're doing, oh, there we go. Where am I at? Let me go back. There it is. Okay. Figure 5-6 uses a single statement and it eliminates the entire decision-making process in figure 5-5. So it's a substantial improvement to the original process. Process logic adjusts easily to new conditions. So there's no logic changes if there are 20, 30, or any number of possible categories. So if we decided that our array could actually, there could be dependents up to 10 dependents, then all we have to do is change the size of the array, but not all the logic. So figure 5-7 on the next slide is the entire application where it takes advantage of the array and produces a report. And we're going to see this one in JavaScript too. So this is the final version of the dependence report program. The final analysis of program changes. Series of decisions worked but inefficiently. Using an array resulted in more efficient code. So if you look at the logic there, and I'll go ahead so I can point to it even though it's little on my screen. Okay, so what it's doing here in our pseudocode is we've got the number of dependents. In our pseudocode, they went ahead and initialized this. Now, what we did in JavaScript was we made a little while loop to put all the zeros in there, right? So that's the only difference. Number quit equals 999s. We said quit equals -1. So enter the dependents or quit to quit. Input the number of dependents. While dependents are not equal to quit, count subdependent is equal to count subdependent plus 1. So why do I not need an if statement? Why do I not need an if statement there? Output, enter dependents or quit, input dependent, end while, and then they do the while loop for that. Because right here, what if I enter a 1 in dependence? Then count sub 1 is equal to count sub 1 plus 1, right? Mm-hmm. So over here, if I've input dependence and say it's equal to 1, then I say count sub dependence is equal to count subdependence plus 1, right? Because I'm just tallying. So when I go here, now this one has 1 in it. And if I enter 1 again, I'm going to put another 1. So there would be 2 in there, right? So it's using the counter so there doesn't have to be any decisions or nested ifs. So let's look at the JavaScript for this. Okay. Did I open it? No, I didn't. Okay, so in this one, the top part is the same. Variable count equals new array 6, variable dependent, and I'm going to try, I should be able to use dependence instead of having to use that index. I don't know why I set it up that way.
That was to initialize the.
But I still could have done that with dependence because it said if I set it equal to 0. Well, this one is exactly like except for the index. Let me try something. Well, I'll make sure we run it this way first. So here we've got 2 variables. It should be the same. We've used this to initialize instead of saying variable count like we did in the pseudocode where we just put all the zeros up here. So we've got a while loop to make sure there are all zeros in the count. Then we prompt the user for how many dependents, and then this is the loop that changed. It has one statement, count subdependents equals count subdependents plus 1. And after we add 1, then we have to prompt again the user for how many dependents until they enter quit. So quit is 9s this time. Yeah, they changed it to 9s. Okay, and then we just print out the array. So let's see how this runs, and then I'm going to change that one thing. So here, enter number of dependents. 1, 0. Let's say 1 again, 1 again, so we can see that it works. 2, 3, 5. Okay, 5 And we should have had 0 and 4, I think. So now 999, and it quit. And yes, there's 0 and 4. So actually when you run it, it doesn't look any different than with the nested ifs, right? But look how much room for error there is on the nested ifs in your coding. Because, and what if you had to do, put it up to 10 dependents? Then you would have to have 10 nested ifs, right? Instead of just the 6. So this is a lot easier way to even go in and edit. So let's see if it'll work, because I'm curious why this was done this way. I'm going to try setting dependents equal to 0. Oh, I know why. Because dependents could actually have a 0. That's why we have to use a separate one here. Because you could actually, you don't want to miss a 0, right? So that's why we used a separate variable here, an index, for just initializing it and also printing it out. And that's pretty common in most any language. You're going to use, usually they don't even spell out index, they'll say sabai. They'll say sabai, and that's a variable name that's usually set up as the subscript of an array. Okay? All right, so we watched, okay, we're going to watch this accumulating values in an array, and then we're probably going to stop for today because that's a lot to consume. Oh, wait, we got, yeah, because there's 2 more sections there. Okay, let's go to videos, chapter 5, accumulating.
Hi, this is Joyce Farrell. Let's walk through accumulating values in an array. Suppose you want to produce a product report like this one. Suppose that you'd sell product numbers 0, 1, and 2. In a real business, your product numbers would probably have more digits in them, but we're trying to keep this example simple. And let's say you just want to produce a report of how many of each product number have been ordered. Here's the logic for the report. The program starts and you declare some variables. You're going to have a product number for the user to input, and then 3 counts stored in an array, a count of how many people have ordered product number 0, number 1, and number 2. You're also going to have a quit constant value that the user will enter when the user is done entering values into the program. You'll ask the user to enter a product number, or the quit value to quit, and then you'll accept the product number from a user. While the product entered is not quit, you will continue to operate a loop. In the loop, you'll simply add 1 to one of the counts, the count that is based on the product number. In other words, count 0, count 1, or count 2. Then you'll ask the user for another product number. So the program operates like this. It starts, you make your declarations, and that sets up in memory an uninitialized product number, 3 counts all set to 0, and the quit value. Then you'll prompt the user for a product, and the user inputs a product. Let's say the first product the user inputs is number 2. That's not the quit value, so you're going to add 1 to count 2. Count 2 equals count 2 plus 1 more. Then you'll ask the user for a next product number, and let's say the user types a 0. That's not the quit value, so you're going to add 1 to count 0. You'll prompt the user again, and let's say the user enters 0 again. That's not the quit value, so count 0 was 1, and now count 0 becomes 2, and so on. Eventually you'll prompt the user, and the user will enter the quit value. Now, when you test whether the product is not equal to quit, it's not equal to quit. It is, and this loop ends. So when you're done, you've got an array that has accumulated the different values. In this case, count 0 was 2, count 1 never had any values, so it remains 0, and count 2 is a 1. You could now display these to produce your report. Thanks for watching.
Okay, so hopefully now what I did have also, or I do have also in that zipped file, is the answer to 1A and B that I was going to go over in class. But you can look at those. Design the logic for a program that allows a user to enter 15 numbers, then displays them in the reverse order of entry. So the JavaScript is what I don't think I gave anything but the JavaScript. Let me see. Chapter 6 examples. Oops, not that one. Chapter 5. Okay. Chapter 5. 1A and B. Oh yeah, here's the also, well, actually if you look at the document, it's just the JavaScript, I believe, if you look at it. So it's just not in the JavaScript form, but it's got everything there like you would do it in JavaScript. So you initialize, which is what we've been doing, and then you, let me make this bigger. Okay, so you're going to initialize your array to 15 elements, and you're setting up an index, an account, and a value. Count is the, oh, here's the name of the elements in the array. So here it says while index is less than 15, scores subindex is equal to 0. And so here's where this is the while loop that will initialize. Oh, it is a little different than JavaScript because you can't use end while in JavaScript. I do still have students doing that. That's why your JavaScript won't run. If you put the word end while in your JavaScript, it won't run. Okay, you have to use a closing curly brace. So let me just, so this isn't as confusing because it's kind of a mixture. Let's open it. Oops. So this one's a real simple one here. We do variable value equals 0, scores equals new, subarray 15, index count. While index less than 15, scores subindex equals 0, index equals index plus 1. And see, it's the opening and closing curly brace. That's the only thing that some people have a struggle with, is going back and forth from pseudocode to JavaScript. And so you have to, that's why on a lot of the problems I'll say now, you can either pseudocode, flowchart, or JavaScript. Because scripting is really pretty close to pseudocode. If you learn to script, it's really like pseudocoding in a language. So index equals 0. So here, they had to go back and reset index equal to 0. Why do they need to do that? Why do we need to do that? What would index be right here if we don't reset it to 0?
15.
15. So it would not process any of this, right? So that's something that's really important. You have to reset index to 0. Then you're going to prompt enter any number and repeat it 14 times. So value equals 1.0 times value. While value is greater than or equal to 0 and index is less than 15, then scores subindex is equal to value, index equal to index plus 1, value equals prompt. Let's see if this works. I didn't test it a while ago. Print the array as entered, and then print the array in reverse order. You see what we did to print it? First we print it starting with 0, right?
Mm-hmm.
And then, wait, we didn't reset. I don't think this is going to work. Let me see. Oh, that sure didn't work. Okay, let's say, sometimes I'll do it with Safari when I say this. No, it's got all those percent signs in the name. Okay, I'm going to say File, Save As, Chapter 5. Now it should run. Okay, enter any number and repeat 14 times. I don't like the way that says that. Oh, it's looping. Oh, I should have started with, okay, so it's going to do them all in reverse order. 6, 7, 8, 9. I'm just going to start over again. So it should stop at the end of 14, right? I don't know if it is. Seems like there it is. Huh. It did undefined. Why did it do undefined there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then it started again. I must have entered, it must have not ended the loop at the right time. And then it went backwards and did all of them. So it did do it in reverse order, but there's some reason it did the undefined. I'll have to look at that. So when you look at those, if you're ready to start your part 1 chapter work, you can look over those problems, show you how to do it. Then your assignment is number 2, A and B, but it's not due till next Tuesday. So if you want to try it, that's why I wanted to go show you that those problems are in that zipped file. So if you want to look at those and then you have questions on Thursday, that's why I wanted to let you know what your assignment is. All right, see you all on Thursday.
Yeah, they're. I'm so sorry I wasn't able to get in this morning. My alarm didn't go off.
Oh,